This little guy packs a huge punch. We're talking about a microscopic speck of nuclear fuel, the fundamental element of the Micro Modular Reactor, or MMR. In its full capacity, a single fuel element, about the size of a walnut, holds the energy equivalent of 2,000 liters of diesel fuel. It represents an unparalleled leap in energy density. But with so much power comes great responsibility. As the fission reactions take place, the uranium fuel is slowly transforming, creating fission products that represent nearly 1/3 of the entire periodic table. These are the dangerous, long-lived radioactive materials that must be contained. The traditional nuclear safety model relies on massive structures to contain radioactivity after a potential failure. The MMR takes a revolutionary approach. It prevents failure at the source, the fuel itself. This is the Fully Ceramic Microencapsulated, or FCM fuel. Millimeter-sized bits of uranium are trapped in tiny ceramic pressure vessels called TRISO particles. And here is the innovation. These particles are encased within a fully dense, impervious silicon carbide, or SiC matrix. This is like encasing the fuel in a diamond. This dual-layer containment uses materials that can withstand extreme temperatures and are highly resilient to radiation. The SiC matrix has a melting point of over 2,350 degrees Celsius, giving the core an immense safety margin. This material science allows for a reactor designed for intrinsic safety. The MMR core has the lowest power density of any commercial reactor ever built, allowing it to easily dissipate excess heat. To remove heat, the MMR uses helium. As a harmless, unreactive noble gas, it guarantees chemical stability, never generating steam or hydrogen like water-cooled reactors. But the ultimate safety lies in the laws of physics. It's called the negative temperature coefficient, or Doppler Effect. If the reactor starts to overheat, the temperature automatically causes the uranium-238 atoms to absorb more neutrons. This instantaneously and inescapably shuts down the chain reaction without moving parts, human action, or external power. The physics of the fuel makes a runaway power excursion impossible. The last critical safety challenge is decay heat. Even after shutdown, the fuel continues to generate roughly 10% of its original heat for days. If this isn't cooled, the core can damage itself. The MMR solves this passively, using the warm puck principle. Like a warm hockey puck sitting in the cold air, the MMR dissipates all excess heat passively and harmlessly into the environment. This is done via simple physics, conduction through the core materials and thermal radiation into the surrounding earth and air. There are no pumps or emergency cooling systems to fail. The reactor can survive total loss of power and total loss of coolant without damage. The MMR is designed to be inherently safe, no matter the accident scenario. Containment integrity is maintained by the FCM fuel. Reactivity control is guaranteed by physics, and decay heat is removed passively and flawlessly. This ultra-safe standard enables the MMR to be modular, deployed in remote areas, and replace polluting diesel generation across the globe. It is the future of resilient carbon-free energy. Ultra-safe, the new standard for nuclear safety.